Hello everyone, and welcome back to the channel. In this video, we'll see how we can quickly set up some of the best performing models on Amazon Bedrock, and immediately start using them with Langchain. So before we get to the coding part of this tutorial, there are 3 important things to consider when using an Amazon Bedrock LLM. First, we look at performance. Where does our target model stand on the current benchmarks? I find artificial analysis to be a good place to compare different closed as well as open source models, in terms of simple metrics such as average cost, average quality, and context length. O1 Preview is still on top, as you can see, closely followed by Google's Gemini 2. Some open source models are starting to catch up, like Alibaba's Qwen 2.5 and our target model for this video, which is Meta's Llama 3.3. We can see it has a solid performance score as well as a low price compared to the rest. It also has a comfortable 128K context window, which is more than enough for most use cases. Okay, so now that we've quickly looked at relative performance and cost for our target model, we need to know exactly how much it's going to cost us on Amazon Bedrock. So we go to the pricing page for Bedrock service, and scroll down to the Model On-Demand Pricing section. Here we can go to the Meta Llama section, and we get detailed pricing for each specific model. In our case, the Llama 3.3 model will cost us $0.72 for each million input tokens, and $0.72 for each million output tokens. And finally, now that we have an idea about the performance of our model and its actual price in Bedrock, the last thing we need to check is the quota or limit for the usage of this model. To do so, we open our AWS console and go straight to the Service Quotas page. We first look for the Amazon Bedrock service, and then we look for our specific model, which is Llama 3.3. Now we can quickly take a look at the usage limits in terms of requests per minute or tokens per minute, and we can see that they're quite comfortable for our local usage. Keep in mind that these quotas are specific to this region, which is the default US East 1 Virginia region. Quotas may be lower or higher in other regions. Alright, let's now see how we can use this model in our code. The first thing we need to do is to install the Langchain AWS Package. Wait until it's done. And there you go. Let's skip the second step for now so we can see why we need it. So, to use Bedrock models with the Langchain AWS Package, we need to import the ChatBedrock class. Our Langchain LLM will simply be an instance of this class, where we need to specify the model ID, which for now we leave as blank, the region as well, and credentials, which are the AWS Access Key ID and the AWS Secret Access Key. Okay, so the first thing we need is the model ID of our Llama 3.3 on Bedrock. Let's go back to our AWS console and go straight to the Bedrock service. Here we first need to make sure we have access to the target model. So we scroll down to the Bedrock configuration section, where we can find Model Access. In Model Access, we can check out the entire catalog of Bedrock models grouped by provider, and we can confirm that we indeed have access to the Llama 3.3 model. So here you can see we've already requested access for Llama 3.3, and it was granted. But let's say we want to use some different model, for example, Llama 3.1, which we don't have access to. If it's available to request, all we need to do is click here and then click on Request Model Access. It takes us to this page where we can pick the models we want to request access to. You can try to unlock all of them at the same time if you want, but let's for example pick these 2. Click on Next, confirm your selected models, and click on Submit. And there you go. Most of the time this will be instantaneous, and as you can see, we already have access to the newly requested models. Now one last important thing to note here for our target model is this label here, Cross-Region Inference. It's a new feature deployed in Bedrock, which routes requests to multiple regions to improve resilience and throughput for model usage. So we go to the Inference and Assessment section, where we can find Cross-Region Inference. And here we can see the different models for which cross-region inference is available. We look for our target model, Llama 3.3, and more specifically, we look for its corresponding inference profile ID. This is the model ID that we need to plug into our Langchain ChatBedrock object. Since we're using a US inference profile, we can set the region to the default US East 1 value. We still need to get the AWS credentials, which are the access key and secret key. Let's go back to section 2 of this tutorial, the AWS Secrets. There are many different ways to log into AWS from your code or terminal, some of them being more secure than others. We will go through those different methods in future tutorials. Our method today is arguably the simplest. We start by creating a YAML file at the root of our project, in which we will store our secret keys. For example, we could have OpenAI with its API key, or in our case Bedrock, with its access key and secret key. In this section of the code, we simply open our YAML file and read the secrets. So we start by importing YAML, we then open the file, and finally we use the YAML safe-load method to read its contents. Let's print our credentials to see what they look like. Let's go get those keys from our AWS console. This time, we go straight to the IAM service, which is short for Identity and Access Management. Here we will create a user, which will have his own access and secret key, and then we'll give this user the necessary permissions to use Bedrock. Let's start with the permissions. So we go to Policies, and click on Create Policy. First, we specify a service which in our case will be Bedrock. We then choose the set of permissions within that service that we want to give through this policy. In our case, we only need the invoke model permission. Finally, we must specify the scope of this permission in terms of resources. We can choose to put all resources. This is generally the wrong thing to do for security reasons as it is overly permissive. It's better to be very specific and restrict the permission to only the set of models or inference profiles you want to use. You can do that by specifying their ARN, which is a unique identifier containing the service, region, and ID of the resource. You can also choose to restrict the permission to a type of resources, for example all inference profiles, or all imported models. For the sake of simplicity, let's keep it at all resources. Click on Next. Now we give our policy a name. Let's call it Invoke Model Policy. Finally, we double-check that our permissions were correctly defined and click on Create Policy. Now that we have our custom policy, let's attach it to a new user. We go to the User section and click on Create User. We start by giving the user a name. Let's call it Bedrock LLM User. Click on Next. Here we need to set the user permissions. Since we have a custom policy, we choose Attach Policies directly. And here we look for the permission policy we just created. If you remember, we called it Invoke Model Policy, and there it is. We just need to select it and click on Next. We check that everything was set up correctly and click on Create User. Awesome! Now our new user is created, and it has the necessary permissions to invoke any Bedrock model. If we want to expand or restrict the permissions on this policy, we can simply click on Edit. Finally, let's get the access key and secret key for this specific user. We go to the Security Credentials section and scroll down to Access Keys. Click on Create Access Key. Here we specify that we want to use the keys for local code, and we confirm that we understand that this is risky and that there are better and safer alternatives. Click on Next. And finally, click on Create Access Key. Now all we need to do is copy the access key, paste it in our local YAML file, and do the same for our secret key. Of course, we're only showing them here for the tutorial, and we'll delete the user right after, but keep in mind these credentials are highly sensitive and should not be shared with anybody. Finally, let's click on Done, and confirm that we have successfully saved the credentials. Now we can go back to our code, and rerun this YAML safe load part to get the real credentials. Let's now use these stored credentials to finalize the instantiation of our Langchain ChatBedrock object. In the access key, we put Credentials, Bedrock, Access Key. And in the secret key, we put Credentials, Bedrock, Secret Key. And there you go. Our Bedrock LLM is ready to be used as a Langchain runnable, and can therefore be piped with other runnables to form any LCEL chain we want. Let's make a simple chain using our Bedrock model. We start by importing the necessary elements to make our chain. We will need the chat prompt template class to write our prompts, and the str output parser class to parse the LLM response. We first create our prompt object using the from messages method. We give it a list of messages. First, a system message containing some basic instruction. Let's say, the task is to answer the question using the least amount of words possible. We then add the user message, which will contain the actual question. Next, we instantiate our parser object. And finally, we pipe everything together into the classic prompt LLM parser chain. For more on Langchain LCEL, you can check out our dedicated tutorial on the subject, or our more recent multimodal RAG tutorial. Finally, let's test our chain on a sample query. For example, what is the capital of Tennessee? And there you go. As requested, we get a one-word answer from our Bedrock model. And that's it for this tutorial. We're going to be using a lot of these Bedrock models in our future RAG videos, as well as other features such as the new Cohere re-ranking API. If you found this useful, make sure you like and subscribe to the channel. See you in the next one. Bye-bye.